Today's lesson will be on lesson 3, and the main objective for this lesson is so you will be able to switch between exponential and logarithmic forms of an expression. So what are logarithms? A logarithm is the exponent to which a specified base is raised to obtain a given value. For example, we have log base 2 of x is equal to 6. So the exponential form is written as b to the x power equals to a, whereas the logarithm form is written as log base b of a equals to x. So I'm going to show you how to convert or how to switch from logarithm form, which is what our example is into exponential form, and then you should be able to work backwards as well. So we're going to start off with the 2, and if you notice, the 2 is in the same location as b, so that means in exponential form that 2 is a base. So we are going to go ahead and write 2, and then we have 6. 6 is in the same position as x, so that means it's really the exponent. So we have 2 to the 6th power. Now we write equal, and we have x. So x is where a should be at, and that's on the right side. So you can change it. 2 to the 6th power equals to x, and that is the exponential form. Alright, properties of logarithm. The first one we are going to discuss is product property of logarithm. If you notice, we have log base b of m times n. We can break that up to log base b of m plus log base b of n. To add logarithms with the same base, we multiply the numbers. So if you notice, we have the same base, which is b, right here, just working backwards. We have b, they have the same base, and if we're adding the logarithms, which is right here, all we're really doing is multiplying the m and the n. Just like the two letters are next to each other, that is implying they are multiplying. So here's an example. We have log base 4 of 2 plus log base 4 of 32. So what we're going to do is we are going to rewrite it as log base 4 of 2 times 32, which is going to be equal to log base 4 of 64. You can also convert it to exponential form to solve for x. So we have 4 to the x power equals to 64. And you are going to notice that 4 to the 3rd power is equal to 64. So that means x is equal to 3. Later on, I will show you how to enter this part right here into the calculator. Alright, second property is the quotient property of logarithm. It basically just means when you're dividing, you're really subtracting the logarithm. Or if you're subtracting the logarithm, you're really dividing the numbers. So same base, again, b. Here's m minus, right, and then log base of b of n. So it's really log base b of m divided by n. So notice it is the first number as the numerator, right? And then the second number as the denominator. So here's an example. We have log base 2 of 32 minus log base 2 of 4. Can be rewritten as log base 2 of 32 divided by 4, which you should know is 8. So log base 2 of 8. You can change it, and you type it into your calculator, you'll notice that it's 3. 2 to the 3rd power is equal to 3. Alright, here's another example. If you notice this one, there's no base number, right? You don't see anything here. Well, if you don't see something, that means there is an invisible 10. Really, there's no space in between. I just put it so that I can tell you that, but you should see it written right next to each other like this. And that just means we have an invisible 10. Alright, so you can do the same thing. Right now, because we're adding the two logarithms together, that is a product property. So it's really just 100 times 1,000 giving us 100,000. And if you really want to find out what that is equal to, that is really equal to 5. So if you were to type this into a calculator, you will automatically have 5 as the answer. Alright, here's another example. Let's go ahead and go over this together. If you notice, we are subtracting logarithms. And if we are subtracting logarithms, that means we should be dividing the 48 and the 12. So that means we have log base 2 of 4. That means 2 to the x power equals to 4, giving us the answer of 2. Alright, now I want you to try one out on your own really quick. I want you to pause the video and then resume when you have the answer. Alright, for this one, we have product property because we are adding the logarithms. So what we want to do is we want to multiply these two numbers together. And when we do that, we get log base 5 of 15,625. Type that into the calculator, you get 6. So, I want you to try another one. Again, pause the video and then resume when you are ready. Alright, this one is subtracting. That means we are going to divide. We divide 486 by 18, we should get 27. So log base 3 of 27, that means that is equal to 3. Alright? So recognizing inverses. Inverse properties of logarithms and exponent. So here's the first property. So if you notice, the left side, we have log base b of b to the x power. All that really means is it's equal to x. So if you have the same number as a base and the big B, you can actually cross that out, giving you x. So here's an example. If you notice, these two are the same, right? They're both 3. If they are both 3, we can just cross it out, and our final answer would be 2x plus 1. Same thing this way. If we have b as a base, and then the exponent is log base b of x, these two will cross out again, and we should have x as the answer. For example, we have 12, and all of this right here, even though it might not look it to you, but that is also all exponent for the big 12 on the bottom. Alright, so if that says 12 and this says 12, we cross this out and we are left with x plus 7 as the final answer. Alright, I want you to try this one on your own. Pause the video, resume when you are ready. Alright, final answer should just be 4x. Alright, change of base. You know how earlier I mentioned to you that we can just simply enter it into a calculator without having to convert it into exponent and doing all that stuff? Well, I'm going to show you how to do that exactly. So if you notice, we have log base b of x. Okay. what we could do is we can change it into log base a of x divided by log base a of b. So I know looking at it like that, it seems like, why are we doing an extra step? Well, a is really going to be just 10, so we don't have to type that in. So essentially, it's just going to be log x over log b. That's what it really means. I wrote the a so that you understand that it is going to be the same thing. Alright, so here's an example. We have log base 3 of 27. So all you're really doing is entering into your calculator log of 27 divided by log of 3. I'm doing it separately right now just so you can see it. Log of 27, typing that into your calculator, you should get something like 1.43136. If you type in log 3, you get 0.47712. And then all I'm doing now is rewriting it, right? So that is log of 27, that is log of 3. So if you type that into your calculator, all at once, not like at a time, one at a time like I did, you should get 3 as the final answer. So if you were to change this back into exponential, remember that's 3 to the what power equals 27. So if you know the exponents, you would know that 3 to the third power is equal to 27. And that's why the final answer is going to be 3. Alright, let's go ahead and try one out on your own. Resume the video when you are ready. Alright, if you type log of 32 divided by log of 4 into your calculator, again, you don't have to do a step-by-step like I did. All you have to do is type log 32 division sign log 4 and then press enter. You should get 2.5 as your final answer. So if you do it that way, you should get 2.5. If you did one by one like I did and rounding, you might not get a perfect 2.5. So be very careful in your workbook and your checkpoint and whatnot. But that is all that we have for this lesson. If you have any questions regarding any of the concepts we mentioned, feel free to reach out to me. I will be glad to help you out.